In today's video, I will be talking about the problem window area. So in this problem, we have to perform 5 operations. The first 4 operations are very simple. The first one is creating a window. The second one is bringing it to the top. The third is putting it to the bottom. And the fourth is closing this window. The complicated part is the operation 5, which requires us to calculate what percentage of the window is visible. So here's the code. Here I will reading the input, and also I created this window structure here to keep track of the size of the windows. These lowercase x and y will have the coordinates for the bottom left corner of this current window, and this uppercase x and y will keep track of the top right corner for this current window. And then the level will keep track of which layer this window is on. So we will be able to see which one's on top and which one's on the bottom. Also, I created this area function to return the area of this current window, which is just the width times the height. Here, to keep track of the windows, I will use an unordered map, and I will map the character IDs to this window, so later on we'll be able to use them and not have any extra loops or anything. So here we're reading a few operations, and just keep on reading it until we don't have any inputs anymore. The first operation is W, and that means we're creating a new window. Here I will reading the the ID of this window, and then the lowercase x and y and uppercase x and y. Here, in between these few inputs, I will reading an extra character because here, as you see in the input, there will be an extra parenthesis outside, and then there will be commas in between the inputs. So we want to skip those useless characters and only take the actual input. So here, this lowercase x and y doesn't actually represent the bottom left corner, and this uppercase x and y doesn't have to represent the top right corner either. So to get the bottom left corner, I will find the minimum of these two using this minimum function, and to get the top right, I will get the maximum of the x and y. Then here I will use this CNT to keep track of the layers for this window. And when we're creating a new window, it's always at the top, so I will increase this total CNT by 1 and set it to this layer. The other operation is when we are changing this window I and moving it to the top. So when we move it to the top, this is the same thing. We also increase the layer CNT by 1 and just set the level for this window I to CNT. Another case is when we are moving it to the bottom. When we are moving it to the bottom, I would just create a new variable here, and it would be subtracted by 1 every time. So every time you set it to this value, it will go even lower and lower, so always at the most bottom part of this current opened windows. And here I'll just start at 0, so I will start at 0 for both of these, because later on it will just start, one of them will start increasing and one of them will start decreasing, so it will start separating and we'll be able to get the layers. And then we will also need to be able to delete some of the windows, so we will just erase this key I from the unordered map, and that will remove the window map to as well. So here, this is the final part where we calculate what percentage of window I is showing on the screen. So here, there will be a few other windows that are on top of it, and then it will be covering up windows I. So we don't have to mind about the windows that are below window I. And that's why here we will only look at the windows that are higher than window I. So the layer should be greater than what layer window I is on. And then I will loop through all of the current opened windows, and check for this window, every window J. We also have to make sure that these two windows overlap, because if window J doesn't overlap with window I, although it is on top of window I, it doesn't have anything to do with window I, so it won't be covering up anything. Then we won't have to mind about window J. So we will only look at window J if they actually overlap. And here I'll use the simple overlap check to see if they overlap. And to do that, we will first see if they don't overlap, because that is easier. So we will see if the leftmost coordinate for window A is greater than or equal to the rightmost coordinate for window J. This means that A is completely to the right of window J. Then, window A is completely to the right of window B. Then that means we don't have to care about window A anymore, because it's not touching window B at all. The other case is when the rightmost x for window A is smaller than or equal to the leftmost x for window B. This means that window A is completely to the right. This means that window A is completely to the left of window B, and then this will be the same for the y. This first part, if the bottommost coordinate for window A is greater than or equal to the topmost coordinate for window B, this will mean that it's completely on top of window B, and this other one will mean that window A is completely on the bottom of window B. So all of those cases will mean that it's not touching, window A and window B are not touching. Then this will represent false. And if none of those cases apply, then we will return true, meaning that window A and window B are overlapping. So here, if they overlap, I will not pushing the window J to our list of overlapped windows yet. I will only get the coordinate for window J that is inside window I, because if there's an area of window J that is outside of window I, we don't have to mind about the area, since it's not since it's not covering up window I, because it's outside of window I. So we will get used the maximum to get the maximum leftmost coordinate for these two windows, and this will give us the coordinate that is on the inside of these two. So we will always make sure that window J is inside of I. This is the same for the bottommost coordinate for Y. So also get the maximum, and then for X, for the uppercase X and Y, which represent the top right corner, we will get the minimum instead. So it will always be smaller than the other one, which means that it's inside of the other one. And then we'll push back this window with the coordinates that we just found using these max and mins. And also here we don't have to mind about the layers anymore, because we already made sure that this current window J is definitely covering window I. So it doesn't matter which layer it's on, it will always be covering window I here. And now I will get the total area that is covered by these other windows. And here I'll use this total area here to keep track of the total of the actual area for window I. And then we can use a fraction to represent the percentage later on. So we'll loop through each of the windows that covered up window I, and we will get the area that is covered up using this function. And we have to use a function because the windows that covered up window I might also be overlapping each other. So we don't want to over-calculate the area that is overlapped. And here I will use recursion to find that. And also I will actually modify the actual x and y's. So then this way later on we won't have any overlaps. So we will find another one that overlaps with this current window. using this index, we will keep track of the which current window we're looking for. And also we have to make sure that the current index is smaller than our list of overlapped windows, because if it's greater than, or if it's equal to this size, this means that we've reached the end, and that means none of the so we have to find one that does not overlap. So if they don't overlap, we will just keep on increasing the index, and we will find one until it actually overlaps, because we can remove a few areas that overlap using these few ifs. And here we'll first check if the index is equal to the size of our overlapped windows. If it is equal to that, this means that there are none that overlaps this current window. Then we can just return the current area of this window, because this whole thing is overlapping the window's I. Otherwise, we will get the area that is overlapping window I, but also not covered up by the other windows. So we will check if the window index that we just found, since we're using this index to keep track of this, and here we also checked if it overlaps or not. This window with the index I and D will always overlap this current window. And here we will check which ones, so we will check both of these windows orientations. The first case is when the current window's leftmost x is smaller than the index window, the window with index I and D's leftmost x. So if this current x is smaller than that, this means that our current window is a bit to the left of this window that we just found. So we can say that this window is to the right of our current window. Then we know that whatever is on the right side will be covered up by this other window, since it overlaps. So we should only get the area that doesn't overlap. And to get that, we will just change the rightmost x. Instead of keeping it as the uppercase X, we will change it to the left X for this other window, because this is the area that are not covered up by this other window. And also you can just give it a layer level of 0, because it doesn't the layer isn't necessarily needed here. And then we will use recursion to get the area of that window again, but this time here we should increase the index by 1, because we're looking at the other windows. And since this only goes up in one direction, we will make sure that the final one will not have any overlaps, so it will always return the full area. And then after we search the area and added that onto the amount of area that isn't overlapped by this other window, we will change our current x to this other window x. We do this so then next time, because we know that the other window doesn't have to completely cover up the right side of this current window. It could be on the, let's say, on the bottom right part of this current window. Then the top part of the window will also be showing. So here's an example of why we need to change the x and y coordinate of the current window every time we do an update. So let's say we have these two rectangles here, and this A will be the window that we're looking at. So this window B is covering up some part of this. And so first, when we get the area, like what we just saw, this leftmost x is smaller than the leftmost x for B. So this means that a rectangle B is on the right of rectangle A, which is correct. So we will get the area from this x to this x. So what we will get here will be the area of this. So we will calculate the area of this rectangle here. And then if we don't change the current x, next time we will look at the y value, and then we will be able to see that this y here is the uppercase y, which is the topmost y value for a rectangle A, is greater than the topmost y value for rectangle B, which means that it is on the rectangle B is on the bottom of rectangle A. So we will have, if we don't change the current x value, then we will get the area of this whole rectangle. And you see, we don't want to get this whole thing because here we have this overlapped area. And so this is why we should change the leftmost. This is why we should change the leftmost coordinate for rectangle A to this to the leftmost coordinate for rectangle B. So this way, when we calculate the areas for the top part of this rectangle, we will only look at the area here. So we will only look at this rectangle, because we already calculated this the area of this rectangle when we found the area on this left side of this rectangle A. So when we change the coordinate to this, when we change the leftmost coordinate to this, our rectangle will only be, so here A will start to look like this instead. And when we get the area, we will just find this area, which is what we want to do. And so this is why we assign this value. This is also the same for the other side of this rectangle, but here we compare the rightmost. If the rightmost x of this current window is greater than the rightmost x for the other window, this means that this other window is on the left side of this current window. So we will basically do what we just did here with the other orientation, but here change the x and y a bit. So now the y will stay the same since we are not changing anything with y but x. So here you, instead of us keeping it as a small x value for current x, we will use the uppercase x value for the other window. So here we will basically get, let's say that this window is on the other side, then we will get whatever, then using this, we will get whatever is over here. So this will be the area that we're calculating using this other if. And then here, this is the part where we calculate the y values. This y value is basically the same thing as the x value, except this time change the variables a bit. And then, so here, since we've already changed our current x, if we already had some areas on the left or right, we won't have any overlapped calculations for this other window. So get whatever is the area on the top using this get area function again. We use this get area function again to make sure that we don't have any overlaps, because the windows that overlap, window I, can also overlap each other, and we should only count those overlaps only once. So this will all be the same. And finally, we'll return the sum of these areas that we got. After that, we will look at the next area. So here we will finish looking at the first window, and then we'll go on to the next window, and just so on. Here, to make this is why we make sure that we don't have any overlap areas for for the windows in the overlapped array, because here we will always increase index, so it won't go back to these windows that we changed already. Plus here we already modified it, the x and the y, so then they will become basically nothing, and then we can just go on to the next window. Finally, we will add the cover areas. This will be the cover area, so we'll add all the areas that we got for each of these windows. Finally, using this fraction, so the cover area over the total area will be the percentage of the area that is covered, and this will be something from 0 to 1, But here we want to get the total area that is showing, so we will subtract that from 1 and finally multiply this by 100 because it's showing in percentage, not in decimal. Then finally we will return that, and we can print out what we got from this get% function.